Hello dear students. In the previous video of this series, we had learned Theorem 9.1 which states equal chords of a circle subtend equal angles at the center. Today we are going to learn Theorem 9.2 which is the exact converse of Theorem 9.1. Converse means opposite. Here the statement says if the angles subtended by the chords of a circle at the center are equal, then the chords are equal. So let us see how this theorem is true. First, I have drawn a circle here. Now let us draw two chords for this circle. Let us first name this center as O. And here I will draw two chords and I will join it with center. So this is chord AB and I have joined it with center. Then we will draw one more chord. Let us name it CD. Let us join it with center. So C with center O and D with center O. Okay, so we have got two triangles here and we have got two angles here. This angle is equal to this angle. Also, using this diagram we can understand that this line segment OC extends from the center of the circle to the circumference of the circle. Therefore it can be called as the radius of circle. Same with OD, same with OB, same with OA. So we can say that all four of these are equal. Now let us go and prove. First we will write what is given. It is given in the statement that angles subtended by the chords of a circle at the center are equal. So these are the two angles. Angle AOB equals angle, let us write DOC. Now to prove AB equals CD, let us write the proof. In triangle AOB and triangle DOC, we can say that AO equals DO because the reason is they are radii of circle, plural of radius is radii. Then we know angle AOB equals angle DOC because it is given. Then we know DO equals CO because they are also radii of circle. And we have got side angle side. So by side angle side rule, triangle AOB is congruent to triangle DOC. Okay, and as CPCT are equal, we can say that the corresponding parts AB and DC. AB and DC we will write it as CD. DC and CD are the same thing. AB equals CD. Hence proved that if the angles subtended by the chords of a circle at the center are equal, then the chords are also equal. Now a thing to notice here is Here we have used the side angle side rule. We have used the side angle side rule and not the side rule which we used in the previous theorem, because here the angles were equal, and in the previous theorem the chords were equal and we were proving that the angles were equal. We were proving that the angles are equal. In this theorem, the angles are equal and we are proving that these chords are equal. So this is how we have proved theorem 9.2.